Welcome, ladies and gentlemen, to this very first international webinar of ENI. ENI is the Dutch cooperative network of companies that try to accelerate the transition towards emission-free, zero-emission construction works, especially in the infrastructure sector, and also focusing on the heavy-duty equipment. So everything above 20 tons, so to say, has our attention. Let me first introduce to you what ENI is and does before we have a chat with our guests who will represent perspectives from the government, from public clients, from the market association, as well as some technical experts. I hope you also have questions. In the meantime, please don't hesitate to put them in the chat. We will try to put questions forward to the table. If that doesn't work out, don't worry, we will answer the questions later on. When we publish the recordings of this webinar, we will also publish the answers to the questions you've been asking. So let's first start with ENI. Who is it? Emission-free network infrastructure, we call it in English. That's a bit gruffy. Emissieloos netwerk infra in Dutch. That sounds nicer. We are a pre-competitive network of about 42 companies. And maybe first let's have a look at who is member of ENI. On the right-hand side, you see roughly half of our members are contractors. We have some of the biggest companies in Holland being member of us. On the left-hand side, we move right into the supply chain of electric equipment. You see battery suppliers, OEMs, dealers, conversion companies. We've got rental companies, finance companies, and lots of in-betweeners. We also got SOMA, what is an educational institute, and we are very happy to have ELAD as a member, what is a foundation in itself, run by the power grid operators in the Netherlands. They are concerned with everything about charging. They set the standards, they are for the safety and interconnectivity of things, so we are very glad to have them on board as well. If you are a member of ENI, you commit to two things. You have to share knowledge and you have to invest in the equipment and in the infrastructure that is needed. And we see that is taking place. We see that it's growing exponentially. So it's time to think about the next step, and that is scaling up. That is why we have decided to host an international webinar to reach out and see who else is out there who is interested to hook on and work together with us in that acceleration of the transition towards zero-emission constructions. As said, we have different guests at the table today. We also invited Arno Visser, who is president of the Dutch Building Association Bouwend Nederland. He couldn't make it, but he left us a message, and we will start with just listening to him for a moment. Here comes Arno Visser.
The construction sector faces huge challenges to reduce emissions like CO and NOx. The members of Bouwend Nederland work hard to achieve this every day, among other things by building more and more with zero-emission equipment. And by redesigning in construction logistics, we also build more efficiently and make up to 70% fewer transport movements to and from the construction site. This not only benefits the climate and our environment, but certainly also construction site workers and local residents. In the coming years, construction companies will continue to invest tens of millions to buy zero-emission equipment, and this will include smaller equipment that is already available in the market, but will focus on heavier equipment that partly still needs to be developed. Much of the investment will go into the conversion market if manufacturers cannot supply the required models. However, we have doubts that conversion alone can deliver the volumes needed to transform the construction sector as fast as we must. We are well aware that as a small country, we have little volume for, and that is why we are committed to collaboration. We are happy to share the wealth of knowledge and experience we have gained in our country in recent years in the field of drivetrains, charging infrastructure, and standardization. Our entrepreneurs are also willing to invest further. Charging infrastructure is needed to encourage this. This also requires clients to tender in a uniform way, and they must be prepared to pay for the deployment of zero-emission equipment. Manufacturers, clients and market players really need to each other. Collaboration, dialogues, knowledge exchange and joint investments are, as far as I am concerned, the keys to joint success. Bouwend Nederland is happy to participate.
So far, Arno Visser, who has left us a message, but now here live at the table, I welcome Erik Wagner from the HWBP, you're director of that program.
Thank you.
And Arjan Walinga from Bouwend Nederland, you're a senior advisor there and expert on the topic at hand at the moment.
Yep, nice to be here.
Welcome, thank you very much for coming. Erik, maybe just to start off with the explanation, the HWBP, it's a mouthful. What is it?
Yeah, it's the Hoogwaterbeschermingsprogramma, which is the Dutch reinforcement of dikes, the dike reinforcement program. And that is a public investment program to adapt, to prepare for the future. As you know, we are largely dependent in our country on dikes and all kind of water constructions. And with the HWBP, we're investing in the existing infrastructure, and we are increasing the infrastructure with all the water authorities and the Dutch government.
So you're a corporation as well?
Yes, we are a sort of public alliance of governmental bodies, regional governments, the national government, and they all joined hands and said we have to invest and have to make a very big performance in constructing and reconstructing our dikes and dams and sluices and pumping stations, everything we need to stay dry and safe. So let's join together, let's invest together. So all these governmental bodies pay for this investment program. And it has been going on for 10 years now. So about 100 dike projects going on. And we invest about 14 billion euro until 2050.
Yeah, that is, I don't know, maybe the biggest governmental program in infrastructure in the
probably.
upcoming 30 years?
Actually, it is the biggest water investment program scheme since the Deltawerken in the 60s and 70s.
Yeah.
So it's even for a country that is used to invest in water safety, it's a big program.
Yeah, and we didn't invite you for nothing as being somewhat of a representative of all your fellow government institutions that procure in the market as well.
Right.
The infrastructure market is estimated about 10 to 12 billion a year from government contracts, all kinds of. And they all go to the market. Arjan, coming to you. Maybe first introduce yourself. What is your expertise at Bouwend Nederland? And maybe also a few figures on the market in the Netherlands.
Yeah, Arjan Walinga from Bouwend Nederland. The association that unites all the not all, but the construction companies in the Netherlands. So a larger part of the construction companies in the Netherlands are a member of our association. There are a number of associations in specific fields. We are the association especially for the construction industry. And we have about 3,000 members. Like 500 members are active in the infrastructure sector. So just to give you some numbers. And working for road authorities, working for the what we call the wet infrastructure, and they face major challenges. And we are also always in close contact with the public buyers, of course, and especially the triangle between market, public buyers, and knowledge institutions, such as ENI is as well, in my perspective. We have to work together to achieve a better solution for a country as a whole. Yeah. So there's no contradictionaries in this area, but there's difficult problems that we have to tackle, and that's what we do as an association. At least we contribute to this area.
Yeah, As I said earlier, ENI is pre-competitive. We work together across market sectors, and we also have established good bonds with governments, with public clients. And what we notice is that we really, as you said, have a common challenge to get the Netherlands dry, to have them safe, but also to commit to the climate commitments that have been given.
Yeah.
But there is another more urgent problem in the Netherlands. Maybe you can address that, Arjan. What is making the move towards zero-emission construction so imminent and so urgent in the Netherlands if you compare them to other countries?
Yeah, we are the first country in Europe that has such strict legislation in terms of NOx emissions. So this is a theme that is valid in all countries in the EU, but not at the top level of what we see. But in the Netherlands, we've got quite strict regulations in terms of applying to NOx emissions to get them lower in order to build. So basically, the Dutch construction sector contributes like 0.6% in terms of NOx, but that's still too much because the what we call the norm, the thing that we have to work to is 0% or even improve. And that's the nice thing. We have a common understanding of this goal, and we all look forward to getting to this goal, both from public side. So there's not a question, should we or should we not get this NOx decrease? We have to. And then we have a goal that we share in terms of going there, because the public clients, they want to make the Netherlands safer. They want to build the dikes, just like Eric said. But the regulation in the Netherlands is so strict that it's almost impossible to work without emission-free material. But we're just a small country. If we have like 300 to 400,000 equipment pieces in the Netherlands, and less than 1%, as I understand it, but you have more figures from ENI, is at this moment emission-free. So we have a long way to go. But we only have 1% of market share in the global scale, and Europe has 16% on a global scale. There's some issues that we have to solve, and I think that's what we have on the table today.
So you're referring to the market share in terms of equipment?
Yeah.
Yeah. Yeah. And for those viewers who are not familiar with NOx, the nitrogen oxide deposition problem in the Netherlands, about 5 years ago, it was 2019.
Yeah. Only 5, yeah.
The law basically put a stop to all construction activities that were going on because NOx depositions in Nature 2000 areas, what are basically everywhere or in the vicinity of them, were too high, were degrading nature, and that became at that moment the hottest issue in constructions, where it became clear we either build zero emission or we don't build at all in a lot of places. Eric, as being the master of dike reconstruction, do you have anything to do with that area? Do you have any problems with nitrogen oxide?
Oh yes, certainly so. The N-word dominates the Dutch market, the Dutch construction in general, and so we sort of suffer from this discussion, and dike projects need to meet the same strict standards as my neighbor mentioned earlier. So it's very hard. We were in a gradual transition towards emission-free machinery, but with the nitrogen problems, there's a sort of catalyst. It works as a catalyst in this transition, and because with emission-free machinery, you can meet these strict standards and regulations. So all of a sudden, a lot of companies and customers, public customers, are moving towards emission-free machinery. And that's what the situation we are at the moment. A few projects of the flood protection scheme cannot go on if they do not solve this nitrogen problem.
So that's really a pickle.
Urgent.
If you can't raise the dikes in a time of climate change where water is just coming up, and our country is sinking at the same time, and you can't build them, so you're basically running a risk at all the assets and all the people that are living after it.
And we cannot afford that, of course. The planning of the scheme is already very ambitious, so we cannot afford any stagnation. So we're putting a lot of pressure on all governments to find a way through this problem. But at the same time, we have to, even more than we were thinking, we have to move towards emission-free construction.
Yeah.
And that is a challenge.
That's quite interesting, because there are the projects that we do in the infrastructure sector are mostly of public interest, like safe dikes. We're talking about storage of CO2 in empty gas fields, for example, which is in the long term good for the environment, but bad for the biodiversity. So there's all kinds of contradictionaries coming up, and ways of working around the NOx regulation. There are none, and we stand firm, because we think we should go to a situation where we work emission free. Absolutely. And this is not only for the beneficiary of the biodiversity or a safe country, but also for the people who are working there. I used to be a logistics manager for Siemens like ages ago, and I can still remember, like 20 years ago, that there were gas running or even diesel running forklifts in my warehouse. And then all of a sudden, the the industry started to deliver electric or gas versions. And if you would now, today, put a diesel forklift in this same warehouse, the same employee would say, "Are you out of your mind? Because I'm breathing in this stuff. So this is not good for us." And this is exactly the same with this issue. It starts with an ambition, then a regulation comes, then it becomes stricter, and then we say, okay, this is something we have to go to, and it's like a catalyst. So we go faster, but the problem is that we cannot make it, like Arno said in his video message, we cannot make it with the retrofit industry alone. We are very creative as a country. We know as a first mover we have to be creative, but we face now first mover disadvantages basically in terms of getting there.
Because there is basically a stacking of motivations why to move towards zero emissions.
So many,
what you mentioned earlier, the NOx deposition in the nature. So that really hits the permits. Can you build at all? You mentioned climate, obviously. CO2 emissions have to go down. We have little other chance in terms of international agreements. And now you mentioned diesel emissions. The fumes of diesel emissions are a substance of very high concern because they are carcinogenic. And they've been put on the blacklist, so to say. So what we have seen already are inspections by the government to see whether we as companies that employ diesel-powered emissions have done everything to shield our workers.
Yeah, as much as possible. Yeah, as much as possible. Yeah.
And there's even a fourth motivation why to move towards zero emission, and those are the municipal Clean Air Acts. I believe, for the last thing I know, 40-odd municipalities have installed environmental zones and have committed to Clean Air Acts. So particle matters from the exhaust pipe in built-up areas are also basically prohibiting the way forward.
Yeah, not only from material pieces, but also from transport means, so like lorries.
Yeah.
They cannot enter these areas where there's a zero emission zone. So this is a big problem.
And there's also the factor of noise. People in the vicinity of a building project and water construction or any construction at all, they suffer from noise problems. So I visited a lot of dike projects, and the last couple of years I saw a few of them with emission-free machinery, and it was really impressive because you could whisper while they were working, and the people who operate these big machines were really happy. They said at first we didn't trust it at all, but now we don't want to go back. I want to stay in this machine forever.
Yeah.
So there is no way back.
So there's really a multifaceted challenge and we found zero emission construction equipment as the answer to all those at the same time.
Yeah.
So there's many arguments to go there. The question is how do we get there sooner than the autonomous process that we are going through?
Yeah. What we have discussed just now, the problems from all the different angles, they have been concerted into one single roadmap by the government, the SEB, Schoon en emissieloos bouwen, basically meaning clean and emission-free constructions. There are different roadmaps for different sectors, the rail, the waterways, the construction on land, and a fourth one I just forgot. They all have their targets, they have their instruments. Arjan, I don't know whether you are familiar with the numbers that come along with those and the instruments the government uses.
Yeah, of course. We follow the SEB covenant because we say this is something that's going to happen anyway, but we are asking for a more smooth introduction, even though legislation tells us to be there, let's say tomorrow or maybe in 2026. So there's a lot of possibilities to get there earlier. The retrofit market is one of them, of course. You can work with subsidies, if I say it correctly in English, putting money into the market. So there's a lot of things, but the most important thing is that we as a country, we invested now 500 million euros via a program, the stikstofgelden, as in Dutch, nitrogen funds. And a lot of companies gained a lot of knowledge from this money. So we have to make sure that all this knowledge will be combined to a product that we can offer in a cooperation with the manufacturers, which work internationally. So it's partially the government can do some things, and partially the market can do also things by sharing the knowledge that we have gained in the last let's say 4 years. And share them with, and this is not only not only has to do with drivetrains. It has to do with loading infrastructure. It has to do with is it feasible or is it sensible to take a battery off a piece of equipment and ship it outside of the construction area to a loading station, or if it's fixed to the machine, do we ship the whole machine from the construction area to a charging station, and is this good for the environment? Of course, no. So we learned not only about techniques, but also how to implement technique in a specific country, in a specific area in a country, like dikes. And what works in a diking project does not mean it also works in a housing project where we do groundwork as well. So this is my reaction to that. Yeah.
That is characteristic of the construction sector. It's very diverse. And just to make sure, the SEB roadmap, I've been calling with the ministry before, and there's about 1 billion euros going in until 2030. And they try to reach out to different dimensions, as you said earlier. There will be money going into subsidies for buying machines. We're not that much of a fan of it as ENI, but there's also going money into public clients as extra finance to get additional finance to address zero emission challenges, but also the infrastructure, as you mentioned, knowledge sharing. Well, obviously the governmental procurement that has to move the market. The infrastructure market is obviously characterized by public clientship. Basically, it's about zero emissions.
We are much more a fan of investing these funds, like this billion, in projects and not only in pilots, because you need the pilots to get the knowledge. But we can also spend this same money, because you can spend it only one time, and invest it in a certain project. Because in the construction industry, innovation takes place in the project. We don't innovate a product, put it on the shelf, and then say, okay, let's use this for this specific solution. So we want to spend it in project, like the project that Eric is concerned.
Eric, what is the HWBP doing on?
Well, I think in general the willingness amongst public clients is really at a sort of maximum at the moment. There's funding. There are very ambitious agreements to make these transitions, and in the HWP we have a financial scheme to sort of subsidize and help this transition. So if a project wants to use emission zero emission machines, we provide some extra funding so they can invest in these machines. And it actually works, because at the moment I think about a few dozen large machines, the cranes and dumping trucks, are in our project active. So we're experiencing this first step of emission-free building. And we know we come to new problems. We are creative and try new solutions for charging. But we're still at the start. But it's because of all these governments that really are willing to invest in this transition. It is a very interesting time for suppliers and for charging companies to step into the Dutch water construction.
Yeah, for markets it's also very difficult to see. We have this institute, it's called the Tendering Institute, the AMC Institute, and they started to measure the number of times that emission-free construction or zero emission is mentioned in the text, and there are all kinds of phrases to be found in these tenders, but they're all different. So there should be a uniform way of tendering to a certain level, of course. So for our construction companies, it is way easier to invest in a certain piece of material because they know it will be used in the market in a special project.
That's something that we as ENI like to pronounce. Let's invest public money in the development that delivers the biggest amount of emission reduction per euro that we put in as being public money. And that comes down to, okay, what kind of models are being used in numbers? What are the models that contribute heavily to the overall emission of the sector? We found earlier in analysis that we did high over, it's not academic work, but we saw that ground moving equipment is one of the big emitters. Cranes, excavators, dumpers. And I believe those are the machineries, the type of machinery that you use a lot in the dikes.
Yes, yes. And at the moment, we have to convert them. So the construction companies, they call the company and the supply company and say, well, please leave out the engine. Because we don't use it anyway, and which is
somewhere else.
It's strange, but that's how it works at the moment. So they convert them themselves, or you have small companies doing that at the moment, and they're actually being used in water construction projects, dikes and dams, in all over the country. I think at the moment a few dozen cranes and dumper trucks at about 10 projects, and that will increase because of the arrangement we'd make, because of the public, the government agreements that have been signed in Europe and in the Netherlands, SEB. So I think that will increase furthermore.
And there's even more machines operating outside the dikes and the water sector. You mentioned 20 to 30. We estimate about 200 to 300 substantial pieces of equipment in the market operating today. And I believe the biggest one was a 275 tons drilling machine. But we've seen pilers, we've seen cranes, crawler cranes, lots of equipment for earth movement. So there's so much happening in the market. If we look back 3 years, ENI has been founded in 2020, and we were happy when one machine came online. You saw that, and there's another machine.
The market was
wait another month to get it. And now we see that the announcements come weekly, and there's a lot of announcements we miss, I believe. Some machines we hear later on that are in the market operating.
A lot of praise for all these initiatives, really. But if you look at the bare numbers, the effect of all these things happening with these very innovative companies doesn't lead to the large volumes that we need. And then we are a small country in the Netherlands, so we don't have too many machines working compared to maybe Germany. So that's why we started an initiative together with you guys to see what will the development of the demand for electric or emission-free material be in Europe? We don't know yet. We expect it will start somewhere in the north, because everything like this starts in the north. Denmark, Sweden, we expect, and then make an analysis of in what term will the market really start to emerge. This is an emerging market starting in the Netherlands. It will grow rapidly, and will the development of this machinery in terms of production versions, will it be able to keep up with the speed that the demand will take? And we have big questions that it will. So we need the international suppliers to step up a bit, especially for the Netherlands, because you will solve our problem, very nice, but there's a big market coming in Europe, even though it's just 16% of the total global market.
But it is inevitable.
Yeah, inevitable.
Because climate commitments are global.
Yep.
We've got the Fit for 55 program in the EU that has been translated to the Netherlands. We've got fixed targets on CO2 reduction, NOx reduction, particle matters, the whole thing about worker health.
Yep.
So there's an inevitability in the movement. So it's a question of speed.
Yeah, and the experience we have in the Netherlands is very interesting for other countries, I believe. And as far as the water construction is concerned, many of the large water construction companies in the Netherlands operate internationally. So the Netherlands is also an interesting laboratory for all the problems you have
playground.
to overcome. So to speak. Yeah.
It is a playground, and there are already OEM manufacturers that bring their machines to us to test them out in real life. Not even waiting for us to buy them, but to bring them and have them tested in real life. What gives a loads of expertise and experiences in actually making them work. We will come to our next guest later on when it comes to technicalities. I certainly wanted to move into the SB roadmap, again, what we talked about earlier. You said it's a covenant. Is the HWBP confirming to the covenant, and are you putting your money where your mouth is?
We certainly do, and there were, before this agreement is signed, it's actually signed late October, I suppose. We have had other agreements, public agreements, which were very strict for us. For example, the Dutch government and the government body for infrastructure, which is called Rijkswaterstaat, together with the water boards, the regional water authorities, have agreed on making the building sites zero emission, emission-free in 2030, which is actually a very ambitious target. But that has been signed before. So we were already working on this transition because of that agreement. And any new agreement will be more ambitious than the former one.
Yeah.
So there's, as I said, there's no way back as far as the public customers are concerned.
Yeah, and it's, as you said, 2030, that's just around the corner, really. And what we have seen is that, how to say, I forgot. No matter.
Building site.
The building site, the move towards 2030, that's what I want to say. The SB roadmap is actually defining technologies coming unallowed on the construction sites in tenders by 2028.
Legislation,
They differentiate between different categories, small, middle, large equipment, and especially the small equipment. They are phased out in government contracts or whoever is committing to the covenant by 2028. And
it's really soon.
That's really soon.
That's
so that
tomorrow.
is
tomorrow,
an investment challenge for the market, because a lot of that material is already available in the market. The big challenge is the development of larger equipment pieces. If you look at, we have one of the questions earlier on the screen, When you look at your current work and the challenges towards zero emission constructions, what are the challenges that really stick out? What is make you lie awake at night?
Two, actually, is the supply, the supply of machinery, of big machinery, and the other one is charging. Charging stations, charging facilities, which is a very challenging problem at the moment. Sooner you will speak to a representative of ELAT. He knows all of the networks. But at the moment we see that many construction companies find different solutions to face this charging problem. So the problem of the availability of power at the right place.
So availability of machinery and
availability of charging facilities.
Yeah. Arjan, from your perspective, any other highlights on what you have to tackle?
I'm a good sleeper, so I don't really lie awake at night. But if I would, concerning this as a topic, I would say safety, because there's we make all kinds of new machineries, which we really need for getting the job done, also with the public clients. But my question is, are they safe? And if we change a battery in a, let's say, pilot project, because it's not OEM products, is it safe? And is it safe for our workers to change the batteries? Is it safe for the workers to work with them? Is it that's not what I lie awake of at night. Is it maintainable? So can we maintain the materials? Is it cost effective? Because in the transition period, we all know that the costs of these machines will rise. In the end, in the long term, it will just go down to the same level. And then again, it's a level playing field for everyone because it's the standard. But safety is my main worry in terms of risks.
Yeah.
So we will get there. We will get there sooner than autonomous. I'm quite sure, and we work together because we share the same goals. That's not a problem. And if we start working together with the international OEMs, we will be sooner than autonomous. But safety is one of the biggest issues that we have to face.
And if you talk about safety, you might talk about technology as well. We have a question here about the possibilities to use internal combustion engines on, for example, hydrogen. So H2 combustion engines. Is any one of you?
Well, I think in the end that is the future way to do things. But the development of that kind of techniques is slower, and at the moment, electric batteries is more available and easier to implement. But we see in the water construction examples of hydrogen cranes. One company in the Netherlands is actually doing a dike reinforcement project with hydrogen cranes. So he developed it himself, which is very interesting. A construction company developed a hydrogen engine, but it works. So it's promising for the future, but I think it will take longer than the transition to electric power supplies.
And then what about NOx emissions? Because they still come out of the pipe.
In hydrogen?
Yeah, if you're talking hydrogen combustion, we still have NOx emissions.
Yeah.
And some people say, like it is with trucks, you've got some OEM manufacturers that say, well, it's going to be hydrogen, it's going to be combustion. You hear Toyota saying it a lot, also for private cars. And you've got a camp that is really going for battery-powered electric vehicles. What we see in the Netherlands is basically 99% is all electric powered. And we do have some use for H2 in the conversion towards electricity.
What we see in the market, that in a specific situation, is in a specific project, a specific solution works. So hydrogen could work in a specific situation, but electric is better in another situation. So the solution in the end, if we look back, like in 20 years, it will be a combination of all kinds of techniques. And let's bear in mind that we don't know what's coming next, because we're thinking in terms of what we know, like three major directions. but there could be a fourth one.
We don't know yet.
We don't know yet. So the production of batteries is not very good for the environment. But you hear all kinds of developments where companies are making batteries that are more environmentally friendly. We have to do with all kinds of issues, societal, like do we use minerals from areas in the world where they don't really care about worker safety, etc. So this is a very complex puzzle, and for complex puzzles, there's never one solution. It will always be a combination of a few. So that's basically what we see. Not one solution works in one project. There could be a combination. That's what we see, and probably what you see at ENI as well.
Yeah. You don't know what the future brings.
No.
And the diversity in the market is evident. Coming back to the market and public clients, we talked about knowledge sharing, we talked about cooperating. If you look forward, what are the things that we would have to step up as a market in combination with public clients, maybe in combination with the government as well, to accelerate even further? What's the next step?
Well, I think what ENI does is very impressive. I mean, that is the way forward, to join hands between companies, communicate with the public client about what works for us and what doesn't, and how can we help each other, share knowledge, even in a competitive environment. I think it's really impressive what, and a good example of what the attitude should be in the sector of construction and water construction to make this transition work. So innovation, knowledge sharing, and a lot of communication between all these stakeholders. That's what we need.
Thank you. Arjan, from your side, what could maybe public clients do different, or?
Yeah, I think where public clients and markets, parties in the market are on the same page, because we have the same goal to make the Netherlands safer and maybe make a bit of money, even though it's really difficult to make money in the construction industry because it's a difficult market. But still, we are on the same page, I'm sure. What we are not on the same page with are the public bodies that are working in terms of regulation, so authorities. So I think the gap between public clients and authorities should be minimized. It's not something that we can do, but something that I will give Erik as a challenge, to make sure that they start making regulation that works, to make sure that regulations in a specific community, like Zutphen, Zoetermeer, or these are municipalities in the Netherlands, is exactly the same for each municipality. So local legislation, nationally coordinated. These are the things that we need to step up. But there's almost no difference between the goals of public clients and the market, I'm sure. So the problem is somewhere else. And once again, the international suppliers, because they really have to step up if they want to save the Netherlands. That's basically my issue. And in the long term, save Europe. That's really something that we need to do. So they need to wake up a bit, I'm afraid, yeah.
Thank you very much for your coming here and sharing your perspectives with us and the international audience that is online. But we've started out with a bit of a chicken and egg dilemma, and what I'm hearing from you is there's a clear idea of what we can do to step up and to accelerate. So it boils down to actually doing it. We sometimes say it's more of a moral question than a technical question. It's more of, do you want to, instead of can you? Well,
we've passed that discussion. I mean, 10 years ago it was maybe a very moral influence discussion, but now it's whether you believe it or not, we have to go this way. So we exceeded the stage of an experiment or something nice to try. This is the way to go, and there's no way back.
We went from moral to an economic argument, because if you do not do this as a construction company, you cannot make this project work. And the same goes for the public client, I'm sure.
Yeah. So the politics, the government doesn't want to change this attitude anymore. They have decided that this is the way to go. So we all have to fit in and adjust and make it work.
It's not voluntary, it's just
In the end, not anymore. As you said, soon there will be new regulations about machine emissions. So the net sort of closes soon.
Yeah. Any last words?
It's a nice and very interesting time, an interesting transition. So join in all the companies and suppliers.
Yeah, it's certainly exciting times.
Yeah, from my side, it's really good to see that there's no contradiction between the parties, but there's a shared goal. And if we have to make sure that we find each other. ENI is doing a very good job at that in terms of knowledge, market, practices, and of course the public clients. So we're heading for a good future, but it's going to be a tricky one. It's going to be difficult but fun, I'm sure.
It certainly is. Thank you very much, Arjan, Erik. Thanks for stopping by and talking to us.
It's right.
What we want to do now is to have a look at more practical things. It all happens outside at the construction site. We can talk a lot here inside. It's all warm and it's dry, but that's not the case outside. We will welcome our next guests shortly, but we first wanted to bring you a bit of an impression what is going on in a construction site outside that has zero emission challenges to tackle. So earlier on, we visited the site of Heijmans, a motorway reconstruction, and just have a look at that video we recorded about 2 weeks earlier. Roll it. We have left the studio now to have a look at one of the projects, the big projects with emission-free ambitions currently underway in the Netherlands. It's the A1 motorway reconstruction, and we've been welcomed by Aafke from Heijmans, one of the founding fathers of ENI as well, to show us around and tell us a bit more about this project and the details about emission-free constructions. Tell us first, what kind of project are we looking at?
Well, this is a reconstruction of a highway, reconstruction and expansion of a highway for 15 kilometers. We're here extending the road, the tunnel, but also groundworks.
Yeah.
And the groundworks we did with an electrical excavator.
So what kind of material do you already have? What kind of machinery?
Well, we have already 4 excavators, but also a big 80 tons crane. Well, in total already 24 pieces, big pieces.
So you've got the machinery, and I believe they're all full electric?
Yes, they are, yeah.
So
yeah.
you need power, don't you?
Yeah, we need a lot of power. But we have here actually 4 big charging hubs.
Yeah.
And the biggest one we are now here, it's a 1000 amp charging hub.
But it's still a stretch of 15 kilometers.
Yes.
I'm curious how you're going to get a crawl excavator down to that hub here.
Yeah, well, some of the machinery can go to the hub, and of course, what you're saying, some of the machinery we have to bring in energy.
I do see a Type 2 connector here.
Yeah, yeah.
That will take an awful lot of time, doesn't it?
Yes, yes. It's charging 20 kilowatt an hour, so that will take 20 hours to charge it fully. Or we have to have the DC chargers, and then we can charge them fast.
Will you get a DC charger here?
We will get it. There will be 4 chargers here,
yeah.
But we have there are a lot of supply problems, so it will take longer than we wished for.
I can imagine. So those are DC chargers, aren't they?
They are, yes, and they're also locked in the container, so only the authorized person can get inside.
Yeah.
And the operator of the excavator only has to charge his machine using this.
Even I could do that.
Yeah, exactly.
But that's still, you can't plug them in all at the same time, can you?
No, no, true. We will have to charge them during lunch, 5 or 4 trucks at a time.
Yeah.
But for the truck driver, they cannot have a chat with each other because they do this in shifts now.
And I already see that one of the battery packs is sticking out.
Yeah, so much higher that it's also higher than the cabin. And that gives next problems because when it's on transport, it's higher than the cabin, and we have to lower transport because otherwise we have the restrictions on the road. These are all the side effects actually that come with electrical working. Yeah.
So much more than is visible on the surface.
Yes, yes. Things were more expensive than we could wish for, and also the side effects of the DC chargers or to get the electricity to the machinery. So there are all kinds of costs that we didn't expect.
So what's the next step?
Well, our situations are really diverse, so we need standard protocols in hardware and software.
So that was a nice peek into the daily operations of what we first thought was just be an electric machine. And now we know there's so much more to it. It's so complex. So it was absolutely great to see. Thank you very much for having us.
Yeah, you're welcome.
And now we go back to the studio with a few other experts in the field. Thank you so much.
Hey, good luck. Bye-bye.
Bye-bye. So that was a sunny day at the roadworks. Back in the studio now, we are joined by three experts who will dive more into the technical details. And maybe to start off, if you looked closely, you saw a few PV panels on the containers of Heijmans. That is not nearly enough to power even one machine. There was a plan to come up to 20 trucks working simultaneously on that project alone, along with a lot of machinery equipment. And that takes so much more energy than those PV panels could provide that you have to compare it to a couple of households being powered all year round just to make one electrical day work at the construction site. So let's start maybe with our guests. Gerard van der Veer, Head of Equipment and Innovation at GMB. Welcome. Dick van der Laar, Director of Volker Wessel's Equipment and Logistics. And we've got Bart de Brij from Elard, where we come back later what Elard is actually doing.
Perfect.
But the question about how much power is actually needed. So we are used to drive a lot of diesel around.
Yes.
But you had a lovely rule of thumb how to convert diesel to electricity.
Yeah, when you look at our experience with the conversion from diesel usage to kilowatt hours, it's around factor 4. So 1 liter diesel per hour means 4 kilowatt hour every hour. That means with a 30-ton excavator that uses around, with a combustion engine, it uses around 20 liter diesel per hour. So it uses about 80. It's more efficient. So our experience is it uses about 50, 55 kilowatt hour every hour. So for a full day of work, we need about 400 to 450 kilowatt hours.
For what kind of model?
And a crawler with 30 tons capacity.
Yeah.
So that's a lot.
And that is, for all viewers that don't know how much kilowatt hour energy is normally in 1 liter of diesel, that is almost 10 kilowatt hours. Yeah. When we convert to 4, so that is 60% efficiency already just by converting it to electric machines.
Yeah, we see that electric machines are much more energy efficient than the combustion engine variety.
Yeah, we said earlier that the construction sector is quite diverse. GMB is a niche player, not small, but very specific. Yeah. What kind of projects do you do?
GMB participates in the water safety program, among other activities. And there we reconstruct the dikes. We build dikes, we reconstruct the dikes, so we keep our country safe from flooding.
So lots of earth-moving equipment?
Earth-moving equipment, yes. Yeah.
And on the other hand, Dick, welcome. Volker Wessels, one of the biggest or the biggest constructor in the Netherlands, depending on how you count. What do you do? What kind of work?
What kind of projects? Well, you probably find us everywhere in the country, and it could be below the surface and even to higher buildings where we build apartments whatsoever. So we are what can be built is what we build. So it is in the energy environment, It's in the roadworks. We have we're one of the larger asphalt companies in the Netherlands, so a high variety of machines and equipment and projects that we operate.
And just shortly, the move towards zero emission equipment, is that all across the board, or is it in a specific sector?
You see it more in public, so in the public environment you see it more. So infrastructure works, you can see that the government is pushing, not only with subsidies but also in the project itself, in the tenders. It could be, of course, a bit more, but it's a level of, you know, we have to start, we have to learn, and the infrastructure has to follow. That's what we see happening.
And infrastructure is a good keyword to introduce my third guest, Bart de Brij. Just explain to us what ELAD is and does, please.
Yes, ELAD is a collaboration of the Dutch grid operators, both DSO and TSO, so Stedin, Enexis, Alliander and TenneT. Founded 14 years ago, and what we try to do is integrate e-mobility into the energy system. 14 years ago, the first electric vehicles started to hit the road. You needed charging stations for them. And we developed techniques, standards, protocols for delaying the charging. So you could use the capacity at night of the grid to charge, not causing a demand peak at 5 o'clock when it's already busy at our grids. But also solutions charging when it's sunny, shaving off the solar peak. Well, we do a lot of standardization, developing protocols, but we also have a big test lab where we test electric vehicles, charging stations. And yesterday we did an event on electric aviation. But we also could help in testing the equipment for charging your sector.
Oh, we hope you do.
Very important.
Because maybe to start off, Gerard, you do have some nice examples of how that goes, the interconnectivity of things.
Connectivity for us is very important. You see that the OEMers, the producers, the conversion companies, they make electrical machines that operate flawless, works very well. And then we need to charge it after working hours. And then the problems start because the connectivity is not yet not yet fully operational and safe enough. So you see an OEMer uses a brand of charging equipment, but we move through the whole country and we use very diverse charging machines. And every time you use a new charging machine, you have to start all over and you have to check connectivity. That's the issue. That's a main issue at the moment.
Yeah. How about you?
Well, in my view, it starts with the trust of the operator. The operator, at the end of the day, if he leaves home today, he leaves a diesel machine, which he turns on the key the next day, and it runs. Now he has to await whether the battery is loaded, whether he can switch the key.
Every morning a surprise.
It's a surprise. So it starts with the basic level of giving the operator the information that he gets trust, that he can do his daily job. Second thing is, of course, that you need the technical department, that they overview the machine. You know, is the temperature right? Is the performance right? Do we see any hiccups? Is the load mechanism working? Do we have the right inlet of power every day and every hour? So that's the second thing. You have the technical overview of the whole structure. And of course, with the new demands of our, how do you call it, opdrachtgevers? The
Clients?
The clients,
Yes.
they want to see some results. So how many savings did you do? What were the hours, you know, that you normally would have done with diesel? So what would be the normal output versus the daily output? So you have to do some analysis as well. So data is key. Yeah. It's key in operating, in analyzing, and in reliability of the machine and the process.
It's now necessary to demonstrate that we meet emission requirements. And with diesel, we didn't have to do it. But when we have to reduce nitrogen oxygen emissions, we have to demonstrate that to our clients. So that's an issue.
So that's accounting.
That's
It's emission
accounting.
accounting, isn't it?
Yeah.
Bart, data, that sounds like connectivity again, the protocols you've been mentioned earlier. Is that also concern of ELAT? What kind of data has been available from machines, from charging infrastructure?
Yeah, certainly. Well, two types of data. Firstly, some data where we would like to know in an early stage what your plans are, so we can invest in cabling, installing transformers for the projects you're going to do to keep the grid ready and be proactive in our investment. But then there's a lot of data for the operation and to not only cost saving, so charge when prices are low, for example, but you not necessarily want to have a connection, a grid connection for your peak charger, which occurs maybe 5 times a year. Yeah. It's very costly to have a large grid connection. You might optimize such an operation by installing a little bit of stationary storage. And that is where new business models come in, where your business merges with energy optimization, grid operators, and new services such as stationary storage. Yeah.
That is a big issue. And part of this group has been working on guidelines on connectivity. For viewers at home, you will find those on our website under the heading of SCEP, the standardization of connectivity of electric equipment, where we also try to make kind of a start. What kind of data should be shared? What kind of protocols should be used? Because maybe you can elaborate on those funny experiences you have. What we heard in that roundtable was that if you have got different manufacturers, different suppliers of equipment pieces, let's say a battery container, a charger, a machine, a switchboard, if they all install it correctly, it doesn't work in concert. And then you start to look for the fault, and you've got 4 or 5 different parties working on the same problem. Yeah. What kind of experiences otherwise do you have to share from your daily work?
I mean, it starts when you have the machine, you plug in the cable, then you need to know what's coming out of the cable, and you need to tell the machine what is coming into the machine.
And it starts with what kind of cable do you use?
Exactly. So it's back to basics. It's in that sense. I think in 10 years we look back that we moved from steam to diesel. Now we move from diesel to electric. So I think it's a fantastic time to be part of. But at the end of the day, it's back to the reality where the reliability for the operator and for the work itself, you know, the machine has to work. So it's all these bits and pieces that you have to challenge, you have to check, and sometimes you have to double check. We had examples where we have a 3-phase connection and one of the cables was only giving 100 volts. These are the things you will find out.
Yeah. And in the beginning, the machine was the central point of interest, and we charge it with a Euro connection. It wasn't safe. On our projects, you have your energy supply, and it wasn't safe to do that because it was a connection you could disconnect with full power. So we said no, we must use the same technology as in the automotive. So only a Type 2 or CCS2 connectors, and gradually. The attention shifted from the machine, which operated finely, to the charging infrastructure and the charging logistics, because we had to transport our energy with batteries, with whatever. So, yeah, it's a steep learning curve.
Yeah, and you're mentioning energy logistics. Yeah. We've got a net, Bart. You've got a grid. That is very dense because the Netherlands are very densely built up. And yet why doesn't it deliver the amount of energy that we use at the construction site?
Well, yeah, construction sites are often the sites where there isn't a grid because it's a new construction. So please give us the time for the permitting, for engineering. As mentioned before, we would like to be very proactive in our investments, but you also have to be proactive to share your plans. Engineering something costs some time, and give it to us. Other things I would like to remark, there are a lot of examples how we rolled out smart e-mobility, which lessons can apply. You mentioned the operator has to be secure of his equipment the next day. Well, years ago we had range anxiety at electric vehicles. People didn't know if they could reach their destination on their battery. Well, investing in a dense network of public chargers solved that issue. Range anxiety, we just did a survey with the Union of Electric Vehicle Drivers. It isn't the thing anymore in the Netherlands, maybe on vacation a little bit, but you can solve that. And the same for you. Requirements. Second thing, municipalities did tenders, and they, of course, had very different hardware manufacturers. But from the start, the Dutch central government, but also regional government, said we want to have interoperability, and they applied a carrot and a stick approach. So first mention it to the market. That's the trend where we're heading. And fortunately, businesses thought, hey, my business can expand faster. It's more scalable if I apply this interoperability. Also a Dutch best practice, and that's where ELAT can help a little bit on technical requirements regarding safety, but also cybersecurity. We're not a certification board, but we can facilitate the process. And of course, you can bring your equipment for testing to our lab, which, by the way, is for free because it's public interest.
So you can bring your excavator to you, testing it for free on all different aspects of connectivity, safety, cybersecurity.
Exactly. Power quality issues, if you don't disturb other equipment on the site. So those are specs we have for a safe operation. From a perspective from the grid, of course, don't you affect the bigger grid in the Netherlands with malfunctioning apparatus. Yes, and that's what we do. Actually, at the moment, there's a big test event for vehicles going on at our lab. And from that, we of course, you have to make an appointment, and we exchange some things we would expect from you. Very important, deliver the equipment and not charged, because otherwise we have to takes a day to empty the battery. No, and we tested on multiple things, and that might help your business in scaling up on a standardized way.
But to clarify, it's not private car owners who came to you to test an individual vehicle. It was the OEM parties that came to test models.
Occasionally there is a consumer says, hey, I got this weird thing. What's happening? And yeah, it's on such a scale that it happens only a few times a year, so we're open for that. But you're probably not working with individual excavator owners, but larger fleets of...
In my opinion, every OEMer who is developing an electrical machine must go to ELAT to test connectivity with all the different types and brands of charging equipment, because that's an issue.
Did you already think as well about requiring such tests before you buy something?
Not really, to be honest, no. So we do check, we do acquire machinery that has the safety level, so the kind of certificates, and we check with the provider that they are, acting and building into the right specs. But we did not test or check that, so that might be an idea to pick up, indeed.
You might we also have the hardware. Of course, car manufacturers do have their own test labs. But for specific purposes, you need very expensive testing equipment, and we have that already. The second thing we see, governments are doing tenders or subsidizing. Yesterday we had the State of the Union, where the Ministry of Infrastructure announced also some money for electric equipment. And sometimes they have the condition that it's interoperable, scalable. So it's not only a one-time subsidy for an innovative partner, but it's a start for a long-term business approach.
Yeah, so that tackles one area where we hit some troubles. That is the interconnectivity and the protocols and stuff. Does it work with each other? But charging such big amounts of energy has also hit a wall in terms of neutron congestion. The grid is full, so to say. We have had experiences in the Netherlands that whole provinces have been barred from new connections to the grid, or new solar parks to be connected to the grid, because it's just at full capacity. What makes it hard to get a temporary connection on a construction site? Certainly if it doesn't stay there for public use later on. Yeah. So what do you do when you don't have a grid connection on the place where you have your machines? What is the experiences? What solutions do you apply? Because you do. Dick?
You have to look at project by project. I mean, every project has something or nothing. And if it is nothing, you have to talk to the client in order to come to a solution, because it's not something you can do yourself, because you're simply adding a lot of cost. And if you're adding cost by moving batteries, then you talk about big money, which is to be paid at the end of the day. So it all comes back into the relationship and the arguments that you are dealing with the client in order to come to the right solution. And the solutions are there. I mean, there are battery packs I think you can get them now to 1 megawatt even. Yeah. So yes, we see the market is offering the capacity slowly, but it's there. So it all depends on the work that you do. Our majority of work is in stable areas. The building construction is largely for a longer time at a certain place, and we have the opposite is that we do daily jobs. Then at the end of the day, the machinery comes back home to the home base where we recharge. But for the longer periods, then you need to work with the solution together with your customer.
At the dike projects, you don't have every 3 kilometer a big connection to the grid. On the ENI side, there's a very informative animation, and that explains that first we look at an existing big connection that we can use, that is not used to full capacity. Mainly activities are during the day, so in the night we can use it. We try to work together to use that one. If it is not possible, we try to get a new connection, but a connection that we don't have to remove after our project, so it can stay for the whole community, to make it a public charging place. And in third place, when that is also not possible, we try to look at decentral energy solutions. Emission-free generator, for instance. If that's also not possible, then we try to do minimum net congestion by using a small connection to the grid, and we use peak shaving. So we use batteries. And during the whole day, 24 hours, you can get the energy from the grid. And when we need it, with high capacity, we charge our machines.
So there's different ways to get the energy to the machine, because what we heard earlier, there's a lot of places there's just no choice. You are working zero emission or you don't work at all due to nature permits. And then you've got that cascade of getting energy either through grid connections or autonomously. And that connects to one of the questions that came in through the chat. There is whether ALAD can safeguard energy supply through the grid.
Well, we're founded on behalf of the grid operators. So if you need a grid connection, you should go to your local grid operators. But yes, we would like to see what is possible and not what is not possible. Keep in mind, a lot of the news is regarding supply peaks. So that's solar generation, while you are causing a demand peak. Yeah. And especially at night, often there is a lot of capacity available at the grid. So you can contact your grid operator. There are account managers. You're doing big projects, so they're happy to support you with one. And see if a tailor-made solution might be possible, that you have an agreement that you use your connection only in the evening hours and not giving feed-in during the day. So yes, we're also in a process from the past 100 years, just connecting you to the grid and operating it to see what is possible in tailor-made solutions, because we also need you.
Yeah. And in our experience, that tailor-made solutions are already on a waiting list. The demand is that big that solutions are also difficult to obtain.
But in the meantime, the data that we can use, to give an example, if I connect my car to the grid to load the battery, then sometimes I need it only after 10 hours. Yeah. So I don't care when it gets loaded. So we need to go to a more
the smart charging solutions.
Smart charging systems, where my car or my energy in the car can be used for other purposes, and at the time I want to leave, I have sufficient power back in my battery to move. Yeah. And if those kind of, so you need open source data, you need really that the machines start to talk, and that we need to tell when do we need it and how much do we need, and then you can reach an optimum.
That's also an innovation for the OEMers. We at this time we have stupid machines. They are not intelligent, and the cars, they became more and more and more intelligent to the point that it communicates with charging equipment. Our machines don't do that. When I want, not yet, of course. When I want to know if my what is the state of charge, what is the progress of the charging, I don't look in my machine. I have to look to the charging point to see that, and that's with any car you can see in the app of the car what's the progress of charging. Yeah. But with the machines that is not yet so far.
Yeah. It connects to another question that's coming in through the chat, basically asking, do you need OEM supplied charging equipment, or
no?
Is it not the way?
No.
No.
We have to connect to the same charging infrastructure as mobility. Yeah. Trucks, cars, we have them. All our
we need a standard, and the standard needs to be deployed.
That's exactly.
That's what we need.
Because when they do that, there is not a building company that commits to one brand of machinery and equipment. So, as an OEMer, you must find position in a mix of brands. And when you commit to deploy or deliver your own charging infrastructure,
if it's not interoperable, if you can't hook up one brand to another charger of the other brand,
Yeah, we don't need it.
it's not going to work.
It's not going to work.
Well, it's going to work if you're in a very monopolized market, which you 100% dominate. Yeah, we've seen that in the past in automotive, Tesla and its supercharger network. But well, in Europe, what we try to do, also with the government and companies, is create an open market where on a level playing field there is competition. And competition is not only good for reducing costs, but also improving quality, service, uptime.
Safety.
And this is just a start. We want to scale and scale fast. And the only way to scale fast is to define some standards and requirements.
Somewhere along the line, because if you move a machine or if you just move the battery, that is related to another question that is coming in, and it's about swapping batteries. Is that a solution for not having any grid connection?
Yeah, we have a broad range of equipment. You have stationary machines that you cannot easily move to a charging location, so then you want to change batteries. And you have mobile machines that can drive to a charging location. So we need flexibility in energy. What's the uses of the machine? Is it a crawler? That doesn't move very fast. It can't go 3-4 kilometers to a charging infrastructure. So you have to bring the charge to the machine. In my opinion, I rather do it with an exchangeable battery than with a transport battery, because then I have one working load. I have to charge it 2 times in the transport battery and then back to the equipment. So it depends on the usage of the machine. What Dick says, when you go back to your home base, okay, you charge it there. Next morning you go on your way. So we need the flexibility, depending on what kind of usage does the equipment.
But you do need fast charging.
Yeah.
Fast charging is, so DC charging is one of the elements that you need in order to be flexible, because the flexibility today, it's at the project where you have the cable, and tomorrow you're at a project where you have nothing. And then what you need is flexibility. And so DC charging, and for those machines that you know that they will be in such environments, then you need flexible batteries. But if you are at fixed positions and then our preference is to work with fixed batteries.
And our preference.
And your preference is with flex. So at the end of the day, we're both right or we're both wrong. I don't know.
Probably business cases will occur. Yesterday we did a conference on electric aviation. And this question also popped up. Can we put in battery swapping in electric aircraft? Well, construction-wise, that isn't a bright idea. However, in public transport in India, with a lot of scooters and tuk-tuks, battery swapping is a very profound business case.
But it
vehicles
depends on the voltage of the battery and how safe is the environment where you can do the swapping of the batteries.
Yeah, in the Netherlands, car manufacturer NIO is
trying it out,
exploring the market. From our perspective, the grid operator, whether you charge on-site with a fast charger or you have a swapping station, it still has to be charged. So again, be proactive in your plans. We like to connect you as soon as possible, but give us a little bit of your...
but it all depends on your energy consumption. Okay, a car with 80 or 100 kilowatt hours on board, why do you need to change it? You charge it in an hour.
20 minutes.
But when you need 400, 500, 600 kilowatt hours per day
per machine,
it's a little more a challenge.
So that might also answer a question that came in earlier, whether we will be stuck with the 22 kilowatt AC charging. You responded to that quite firmly. That's not going to work out.
We need DC.
We saw that in the movie one truckload would take 20 hours to charge. It would give you 4 hours a day in operation.
Yeah.
There's
Nothing to add.
not a chance to it.
Correct.
We've got another question about standards, and you kind of touched on that. You were asking the construction companies to come in early to realize grid connections, that they inform us early, and even before that come the standards. One of our guests says, the one with the best standards will win. What we hope to provide is here some feeding to avoid a situation we had, for example, in mobile phones. It was just recently in the news. It took 14 models of iPhones to come to a uniform connector USB-C. We don't need 14 models of excavators on different individualized connectors and protocols. It's not going to work.
Exactly.
So if you're looking also at technology, another question or topic that came in earlier, we are talking lots of batteries and electricity. So where's the room for other forms of propulsion? Is there any room?
Yeah, well, definitely there is a room. At the end of the day, if the business case is right, the technology is there, safety is guaranteed, then yes, there is room.
For propulsion, of course, there's no room for combustion. Whatever you combust, it gives emission. The route is to zero emission. So all types of propulsion, but not combustion.
And this is regarding propulsion. Big thing nowadays for vehicles is bidirectional charging, so vehicle to grid. Yeah. We have to see how this works out in your sector. But if you have a battery of 400 kilowatts, which isn't used in the weekend, you might do some energy services with it, making a bit of money. And in a business where margins are small, in addition, in a totally new market, I think students, consultancy firms will probably look for business opportunities on your behalf in the coming years.
It may be wishful thinking, I don't know, but there is still a voice in the back of my head that says, you know, we have these big oil companies, you know, and they are going to lose their
business,
their current business. Yeah. But I don't know if in their own R&D departments they are still working on, how do you say it, non-combustible fuels that will still make us able or enable us to work emission-free. I don't know.
Every big oil brand profiles it as an energy
supplier
company, not only as a fuel.
We have touched a lot of things. We haven't touched a lot of other things, but we are running out of time, as we have already filled 1.5 hours with quite an interesting conversation. So we have to kind of come to a conclusion in terms of if anything that you want to give, especially to OEM parties in the world, what requirements do you have? What is the thing they keep in top of mind when they leave here?
Standard is a given. Yeah. Please follow. Yeah. And data, make it as open as possible.
We need operational data, state of charge, charging process. We need access data. When it goes wrong, we need to know it. Proactive, and we need analytical data. We have to, how do you
know
say
what's
it?
going on?
Yeah, we
to
have
report.
To report. That's what I said. We need to report our emission requirements.
Yeah. So, yeah. Last thing, test it. Come by. It's for free. Let's check if your standard is the same as my standard. It helps your business. It helps scaling up zero emission building.
And we still have time. I mean,
not a lot if you're asking the clients. because 2030 is just around the corner. But we're here to accelerate the development. We've heard a lot about standardization. We've heard a lot about, not a lot, but we heard combustion is not the way forward. E-fuels and stuff, it's not going to work for all the different kind of emissions we have. It's not just CO2, it's NOx as well, it's particle matters. We've heard there's lots of things coming along with the electric machine. Your way of working changes, your way of cooperating with grid operator changes. Even the role model of client and contractor changes, because sometimes you see that clients need to think about grid connections before they even tender in the market. So there's lots of it. ENI has been producing guidelines and advices on a few of those issues we put on the website to be picked up by the market, by standard setting bodies with a mandate to actually do it, on safety, on standardization, on interconnectivity. And we will come to a conclusion now. Dick, Bart, Gerard, thank you very much for coming in. If you have further questions that haven't been answered in the chat, we will come to those later when we publish a recording of this webinar. It will be accompanied by the answers to those questions. And as Arno Visser said, the construction sector in the Netherlands is eager to collaborate, to cooperate, because we must. There's just no option to postpone it because we are in the squeeze with legislation and commitments that have been given. So what we have tried here is to make a compelling case on the acceleration of this transition in zero emission infrastructure, especially in the heavy equipment, where a lot of the emissions are coming from. Thank you at home very much for listening in, for your questions, and we will conclude with a short summarizing animation to highlight a few points we have seen coming across. And with that, I thank you very much, all the guests, you for listening. Keep in touch. Have a good day. Bye-bye.
On the way to the zero-emission construction site, we're undergoing two transitions: the energy transition in general, as well as the technology transition to emission-free machines. The energy transition involves us moving from an energy system based on fossil fuels to a system based on renewable and emission-free sources. With the technology transition, we're moving from the combustion engine with a mechanical powertrain to an electric powertrain. Although both transitions are comprehensively interlinked, they can also be considered separately. And in the current phase of the energy transition, that is even advantageous. The electricity grid in the Netherlands has reached full capacity. It's very difficult to get more grid capacity at a construction site or for a home. At the same time, the development and availability of electric equipment is increasing by leaps and bounds. Thus, the energy transition is lagging behind the technology transition. This is why some contractors are not buying electric equipment now, because it's impossible to charge due to the deficit in grid capacity. But buying a new machine with an internal combustion engine is not a good idea either. These machines have an average lifespan of 8 to 12 years, and there is a growing possibility that this equipment will soon be banned from use. More and more places have restrictions on local emissions of nitrogen oxide or particulate matter. Permits for nitrogen oxide emissions are already very hard to come by. Given the faster technology transition, it makes more sense to purchase electric construction equipment now. If electricity really cannot be arranged at the construction site, installing a clean diesel generator set is still better than using a diesel machine. A clean generator set produces fewer emissions because of its constant speed. Moreover, you can immediately build emission-free as soon as clean electricity does become available, and that might be on the very next project. There is a logical prioritization to get power to a construction site, despite the fact that temporary, high-load grid connections are hardly available currently. First, look at the nearby companies that are not fully utilizing their grid capacity. This capacity is readily available and does not cause additional grid congestion. If that fails, Option 2 is to establish a grid connection that remains available for public benefit after construction work is completed, such as public charging stations. If that too is not an option, consider an autonomous energy source in the form of a renewable generator set on green hydrogen or biogas, or work with exchangeable batteries that you charge somewhere else. The last possibility is to establish a temporary grid connection at low capacity specifically for charging construction equipment. In combination with a buffer battery, this provides 1 megawatt-hour of power per day at minimal grid congestion. This logical prioritization helps us proceed with the technology transition independently of the energy transition. Much is already possible in the field of renewable energy, and project-specific solutions already minimize the use of generator sets. Electric equipment is thus always better than internal combustion engine equipment.